screen visible to you?
Yes, sir.
So we will discuss series of real numbers. Basically, this series of real numbers. So so if you have infinitely many numbers, just add them. That is a infinite sum, right? So let xn be sequence of real numbers. If xn is a sequence of real numbers, then infinite sum xn is called as series of real numbers. Right, so if you have infinitely many numbers, just add. But here the position of numbers is fixed. So uh, here xn is called as nth term of the series. So thus, what is the meaning of summation x raised to n? N is from 1 to infinity is uh, x1 plus x2 plus x3 plus and so on. So if you add these infinitely many numbers, then it is called as a series of real numbers, right? So for example, if an is equal to 1 upon n, right? Then can I say that an is a sequence of real numbers? Right, an is a sequence of real numbers. Therefore, if you look at summation of all these numbers, that is 1 by n, n is from 1 to infinity. So what is it? 1 plus 1 by 2 plus by 3 and so on. And how many terms we are adding? Infinitely many, right? So is a series real numbers. So what is this nth term? Nth term is an, which is 1 by n, correct? Is it clear what I am saying?
Yes, sir.
Yes, sir.
Now the question is, given a series, when I say series of real numbers means the sum of infinitely many numbers, and remember that their positions are fixed. So this is a first term, this is second, this is third. So in general, we cannot change the positions. We just take infinitely many numbers, add them, and then mix them and then add. That is a different story. So mixing creates a problem in general, right? So we cannot say that in our usual addition 2 plus 3 plus 5 is same as 5 plus 2 plus 3. So we can mix the numbers and then add, doesn't matter for finite case, because we have only finitely many numbers, 3 numbers. But if you have infinitely many numbers and add them and again mix up and then add, so that creates a problem, right? And therefore if something is infinite or adding infinitely many numbers, it is difficult to guess what is the sum. So given a series an of real numbers, right? So an means what? n is from 1 to infinity. That means first is 1, then a2 plus a3. So what is the guarantee that this sum is finite? Right, so this is a natural question. If we are adding infinitely many numbers, what is the guarantee that this sum is finite? That is, sum is a real number. Right. So sum is a finite means it is some number, real number. Infinite means it is not in real numbers. Right. So this is a question. How? What is the guarantee? If you are adding infinitely many numbers, is this sum finite? Right. So if sum is finite, then only it makes sense. If sum is infinite, then it is not of, in general, not of our use. If something is infinite, it is not in our control. So we are interested in check whether the sum is finite, right? So a series an of real numbers is said to be convergent. Convergent if the sum is finite. Is a finite number. Right, so the definition is clear when we say that series is convergent if we add if the sum, right, the total sum is finite number. Otherwise we say that series is divergent. Is divergent. Otherwise means if this sum is not finite or is not a fixed number, finite number, then we say that series is divergent. Okay, so is it clear what I have written? What is the meaning of series is convergent? Do you understand?
Yes, sir.
Right. If this we are adding infinitely many numbers, if this total sum is a finite number, then we say that it is convergent. Otherwise, divergent. Now, question you can ask: ki sum of can a sum of infinitely many numbers be finite? Right? Can a sum of infinitely many numbers be finite? So that we can. Uh, so these are the questions, and we want to answer these questions. Right. Now, let suppose we have this series of real numbers of real numbers. Let x1 is equal to a1. What is the first term of the series? So our series is this: a1 plus a2 plus a3 plus and so on. So infinitely many numbers in this summation. I will call first as x1. Now x2 is a1 plus a2. Right, so I will call x2 as a1, sum of two terms. All right, I will call x3 as a1 plus a2 plus a3. Right. Now a1, a2, a3, a4 all are real numbers. So is x1 real number? Is x1 real number?
Yes, sir.
Right. X2 is a real number
Yes.
because it is sum of two real numbers. It is a finite number. X3 is a sum of three numbers. So in general, xn is a1 plus a2 plus a3 plus up to. sum of first n numbers in the series, sum terms in the series, right? Now, what is 8 x10? Can you tell me what is x10? What is x10?
A1 plus A2, A plus A3 up to A10.
Up to 18, right? Now, so then, can I say that xn is a sequence of real numbers? Is it a
Yes, sir.
sequence? Right, because these are numbers. And x1 has a specific value, x2 has a specific value. We cannot change the, we cannot say that x1 is, we cannot interchange x1 and x2 because x2 has a meaning, the sum of two terms in the series, right? So, what is x1? x1 is this, x2 is sum of two numbers, x3 is sum of three numbers, x4 is sum of four numbers. We are adding one by one every time. So xn is a sequence of, what is a sequence? Sequence of, and there is a relation between this sequence and original series in. What is the relation? We are taking some terms from the series to construct the sequence xn. So, but uh, we are summing or choosing adding terms from the series. Do we add all the terms in the xn at a time?
Just first n terms from the
Right.
sequence.
So it is a sequence of partial sums. We are adding partially, right? Sequence of partial sums of series an. Right. So sequence of partial sums of an. N is from 20. So take a partial sums. But x3 means take sum of first three terms. X4 means take sum of first four terms. So sequence of partial sums. Now you observe this. You observe ki what is x4, what is x5, what is x6, and suppose I increase n, and as n, if I am increasing n, ultimately what is happening? Xn is sum of n terms. What is xn plus 1? Add an plus 1, correct? Now as n tends to infinity, suppose I keep on increasing my n, and what will be the effect on xn? What will happen? You understand? If I increase value of n and now I am letting n tends towards infinity, what will happen? Do you understand what will happen? If I increase value of x4, x5, x6, x7, keep on adding more and more terms, and as n tends to infinity, what will happen? At infinity, as n tends to infinity, what will happen in xn?
It would be the sum of
All the
first
terms,
sequence.
all the terms in the series. As n tends to infinity, if I increase n and n tends to infinity, I will add, then all terms of the series will be added now. Is it clear?
Yes, sir.
Correct? Right. And therefore, so there, then series an is convergent if, suppose if I take limit as n tends to infinity of xn, that means I am adding all the terms, and if limit of xn exists, what will happen? So when I say limit as n tends to infinity xn, what does it mean? The increase value of n plus 1, n plus 2, n plus 3. That means ultimately what will happen in this summation? I have to add an plus 1, an 2, and as n tends to infinity means what happens if we add all the terms? If limit of this exists, then ultimately what will happen? Then the series an is convergent if. sequence xn is convergent and sequence xn is convergent and what is the total sum of series? Do you understand what is the total sum of series?
Limit of xn.
Right, limit n tends to infinity xn, and it is not very difficult to imagine because as I say n tends to infinity, that means in xn I am adding all the possible terms, and as n tends to infinity all the terms are added. As n tends to infinity all the terms are added, and if this limit is x, that means if all the terms are added, then we get value finite number x. That means if sequence xn is convergent, then sum of series, that series is convergent or sum is finite, and actually the sum is limit of sequence, right? And therefore this is an important point. What is a when sequence is convergent? So sequence is convergent. So series an is convergent if the sequence xn is convergent and sum of series is nothing but a limit. So is it clear? Therefore series an is convergent. Thus series an is convergent if and only if the corresponding sequence of xn of partial sums is convergent. Corresponding sequence of partial sums is convergent, and the sum of series is limit of sequence xn. So this is what the important point for us. So now this sentence is clear. Last sentence is clear.
Yes, sir.
Right, fine. So this is a key point, because once you understand this sentence, the next job will be very easy. So let us see this. So consider a series r raised to n. N is from 0 to infinity. Consider this series uh, where r is some real number, fixed real number r. Right, so look at this series. Now basically what is this series r raised to n? N is from, now I am starting n from 0 to infinity, no problem. Anyhow the notation doesn't matter. I have some sum of infinitely many numbers, that is the point. So what is it? 1 plus r square plus and so on. Right, this is infinite sum. So let construct sequence of partial sums. So what is xn? Because if I want to check whether this sum is finite or not, first step is just look at sequence of partial sums. So r plus r square up to r n minus 1, you can say. But by summation, this formula, what is the sum of these n numbers? 1 minus r raised to n upon 1 minus r. Am I right? This is just our usual formula. Which formula we are using here? Which formula? A raised to n minus b raised to n is a minus b into a raised to what? A raised to n minus 1 plus a raised to n minus 1 into b. Is it correct? General formula. And then a is equal to 1 and b is equal to r. Then this formula you have already learned. The sum of n terms So fine. Now we found the sequence of partial sums, right? This is true for each n. Therefore, xn is equal to 1 minus r raised to n, 1 minus r for each n. Then xn is a sequence of partial sums. Then xn is a sequence of partial sums of the series r raised to n is from 0 to infinity. Okay, so each and every sentence is clear, whatever I am writing.
Yes, sir.
So next, okay, note that. So limit r raised to n as n tends to infinity. What is the limit r raised to n as n tends to infinity? R is a real number. What is it? What is this limit? Yes.
Infinity if r is greater than 1,
Uh,
and 0 if r lies between 0 and 1.
right, correct. 1 if r is equal to 1 and infinite if r is greater than. Very good. So it depends on r actually, right? So therefore, what can you say about limit as n tends to infinity xn? What is our xn now? What is xn? Limit as n tends to infinity 1 minus r raised to n upon 1 minus r. What is this limit? Can you tell me this limit? 1 minus 1 upon r is constant, no problem, right? So r is a number. R, we have fixed some real number r, and so 1 upon 1 minus r is a constant, so just limit of 1 minus r raised to n, right? So what is this? Not limit n tends to infinity of 1 minus r raised to n. What is limit? What can you say about this limit? 1 minus 1 minus r into, so if 0 less than r less than 1. Why? Because limit of r raised to n is 0 if r is less than 1 and greater than 0. So therefore it is 1. What is if r is greater than 1? What is it if r is greater than 1?
Minus infinity.
Because here we have 1 minus r, which is negative. Is it plus infinity?
Minus infinity.
But what is here in the denominator? 1 minus r. So if r is greater than 1, 1 minus r is negative.
Yes, sir, got it.
Right. And at r is equal to 1, this is undefined. Right. Because denominator is 1 minus r. So if r is equal to 1, then also it is undefined. So that limit you can check, it is still infinite. So it's infinite if r is equal to 1 by other way you can. So therefore, what is the conclusion? Therefore, so limit, so sequence xn, sequence xn is convergent if 0 less than r less than 1 and divergent if r is greater than or equal to 1. Okay, this sentence is clear. This sentence is clear? Yes.
Yes, sir.
Fine. And by our previous discussion, what we should say? Limit of sequence of partial sums exist, then that is the sum of series. And therefore, what is the sum of series? Therefore, what is the sum of series r raised to n? N is from 0 to infinity, which is 1 plus r square and so on. What is this sum? What is sum of series? Limit of
1 upon 1 minus r if
right.
r lies between 0 and 2.
Limit of sequence of partial sum. So this is 1 minus r if 0 less than r less than 1, and it is infinite if r is greater than or equal to 1. Right? So this is called as a geometric series. Right? So thus geometric series r raised to n converges if 0 less than r less than 1, and divergent if r is greater equal 1. So this is what you have already learned in 11th 12th standard, ki geometric sum is 1 upon 1 minus r. So why? Because corresponding sequence of partial sums converges. Right, so let us see example. Now you tell me what is 2 by 3 raised to n. N is from 0 to infinity. Can you tell me the sum of this series? Right, so what is it? 1 plus 2 by 3 plus 2 by 3 square and so on. So what is r here? 2 by 3. Is it less than 1? Yes.
Yes, sir.
Therefore, by our previous discussion where it converged 1 upon 1 minus r. Right. So 1 upon 1 minus 2 by 3 because r is less than 1. So 3 minus 2, 1. So it is 3. Correct?
Yes, sir.
Right. And so here are infinitely many numbers we are adding, but this is the power of mathematics or logic. Ki we can understand in few seconds ki this sum is 3. But how many numbers are, and if you try to add these numbers manually, keep 1 plus 2 by 3, then 2 by 3 square add, then add one more number, then add one more number, and if you keep on adding, then when will all terms be exhausted? How much time will be required to exhaust all the terms, add all the terms? Right, it will not be possible in finite time, but as a mathematical power, we can say that if you add all the numbers, all the terms, the total sum will be 3. That is what the point we need to understand here. So you now think about 1 by 2 raised to n. N is from 0 to infinity. You just think about it. Now, now I am making some small change. So 2 by 3 raised to n. N is from 1 to infinity. The same example, what is the difference? What is the difference?
First term.
So it starts with 2 by 3. 2 by 3 square, right? Because n is initial value of n is 1, and therefore it starts with 2 by 3 raised to 1. Here initial value of n was 0, so 2 by 3 raised to 0 was 1. So that is the difference, right? And you check this. And what is the sum now? You tell me what is the sum. You can do it
2.
alternately.
2.
2. Because one is not here and one is added in the previous parts, or alternatively you can look at this 1 plus 2 by 3 plus 2 by 3 square and so on, and then it is like a previous one, and see what happens. Right, 3 3 get cancelled because this bracket will be 3 now. 2 by 3 into 3, so ultimately it will be 3, or just one is reduced. So in that way you can understand what is your initial term that affects. Right. Now, this example which you were aware of, so let us see some non-trivial example. Consider a series 1 upon n into n plus 1. N is from 1 to infinity, right? So here we cannot start with n is equal to 0 because n is in the denominator. Okay, so now we want to discuss the convergence of this series, right? So discuss the convergence means we have to check whether it is a convergent or check whether the sum is finite and what is the number to which it converges. Okay, so what is the first step? Let us think about. So uh, let let us consider sequence of partial sums. So xn is equal to 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon n into n plus 1. Do you understand this? What is x1? What is x1? We'll add only one term because what is this series? N is equal to 1, 1 into 2. N is equal to 2, 1 upon 2 into 3. 1 upon 3 into 4. So this is not a decimal point. This is multiplication. Remember this. Dot means here not decimal point. It is multiplication. Right. So this is our series. What is x1? I want to look at a sequence of partial sum. So what is x1? Correct. What is x2? Do you understand? Xn means sum of first n terms of the series. And so x1 is a sum of one term, so only one term. X2 is a sum of first two terms of the series. X3 is sum of first three terms of the series, and so on. Is it clear? So Xn. Okay, is it clear?
Yes, sir.
Yes, sir.
Then Xn is a sequence of partial sums for the series. Right, and n is from 1 to infinity. So you should always worry about what is the initial n, right? Sometimes you need to start with 0, sometimes you start with 1, sometimes starts with 2. It depends on your series, right? So note that, and we have already discussed this sequence, right? This is a sequence now, and we have already discussed this sequence. Do you understand? Do you remember? Note that 1 upon k into k plus 1 by partial fractions, it is 1 by k minus 1 by k plus 1. Is it true?
Yes, sir.
Right. And therefore, can I simplify my sequence xn? Yes. Can I simplify? So I can split 1 upon 1 into 2 as 1 by 1 minus 1 by 2. Right. 1 upon k into k plus 1 can be splitted in this way. So 1 upon 1 into 2 is this. I can split in this way. Second term 1 upon 2 minus 1 by 3 and so on. What is the last term? 1 by n minus 1 by n plus 1 and in between all the terms. But due to this splitting, what happens? Half cancels with this next half, right? So 1 by 3 cancels with, there is 1 by 3 in next bracket. So that means the second term in the previous bracket cancels with first term in the next bracket, right? The second term in previous bracket cancels with next term in uh, next bracket. So 1 by n is the first term in this bracket, it cancels with second term in previous bracket. So for minus 1 by n plus 1, there is no next bracket to cancel. So ultimately what remains? Is it clear? Whatever I have written is clear, is correct.
Yes, sir.
So all in between terms will get cancelled, so only this will remain. And therefore xn is this. So this is a sequence of partial sums. So what is limit of, now let us see what is the limit of sequence of partial sums. Limit of 1 minus 1 upon n plus 1. And what is this limit? What is this limit?
1.
1. Because limit of 1 upon n plus 1 is 0. So limit as n tends to infinity, 1 upon n plus 1 is 0. Right? And therefore ultimately this limit is 1. And hence, so what is sum of the series? Right? What is the
1.
sum of, right?
1.
So limit of sequence 1. So there are infinitely many numbers, but we can in a few seconds we can say that the total sum is 1, not more than 1. Right? Therefore series is convergent and it converges to 1. Therefore converges to 1. So let us see some examples which we have already discussed in previous. So consider series 1 by n square. Of course n starts from 1 to infinity because discuss the convergence. Remember that key, whether the sum is finite or not, that means whether the series is convergent, it is, we are interested in that answer, that question. We are to finding exact value, exact sum is a difficult job, but whether sum is finite or not, that is easy to determine. So consider, construct, what is the first step? Construct a sequence of partial sums. Xn of partial sums. So what is xn now? You tell me what is the sequence of partial sums. What is x1, what is x2, what is x3? What should be x1? What should be x2? What should be x3? In general, what is nth term of sequence of partial sums? So what should be x1? Is it correct? X1 is 1 by 1 square, only first term of series. What is x2? Sum of two terms. Because when I say 1 by n square, it is 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square and so on. Infinite sum, right? So what is xn in general? I want to look at the sequence of partial sum. So what is the nth term of that sequence?
1 plus 1 by 2 square plus 1 by 3 square up to 1 by n square.
Right. Now, and there should not be confusion. The nth term of series is 1 by n square, but nth term of sequence of partial sums is this. Nth term of sequence of partial sums, right? And an is equal to 1 by n square is nth term of series. There is a difference between nth term of sequence of partial sums and nth term of series. So nth term of series is an, which is 1 by n square. But nth term of sequence of partial sums is sum of first n terms of the series. So there should not be confusion. So, note that. What can you say about this sequence? First point, xn is monotonic increasing. Is the sequence monotonic increasing? Is it true?
Yes, sir.
Yes, sir.
Right, because by our theory from sequences, it is clear that xn plus 1 is a greater than xn, monotonic increasing. Now, xn is bounded above. Why? And we have already discussed this sequence in while talking about sequences. Is xn bounded above? Yes. What is xn? 1 plus 1 by 2 square, 1 by 3 square, 1 by n square. This is my xn. Okay, now I will keep 1 as it is, and I will replace 2 square by 1 into 2. I will replace 3 square by 2 into 3. I will replace n square by n minus 1 into n. So which sum is larger? Do you understand? 2 into 2. 2 square is replaced by 1 into 2. So this denominator is smaller. Therefore this sum is larger. 3 into 3 in previous step is replaced by 2 into 3. That means 1 factor 3 is replaced by smaller factor. So therefore corresponding sum is larger. N into n is replaced by n minus 1 into n. So is it correct? This is larger.
Yes, sir.
And again by the previous series, I can split 1 upon 1 into 2 as 1 minus half plus 1 by 2 minus 1 by 3 and so on, 1 by n minus 1 minus 1 by n, and see what happens. 1 plus 1, half cancels, this cancels. So this cancels, so ultimately what remains? This. And can you say that this quantity is less than or equal to 2? Is it true?
Yes, sir.
Therefore, what is the conclusion for all n? Therefore, xn is bounded above. Right? And so can we declare that xn is convergent? Therefore, xn is so why sequence xn is convergent? Why sequence xn is convergent?
Convergent.
So xn is monotonic increasing and bounded above by monotone convergence theorem. Sequence xn is convergent. And therefore, can I declare that ki series is convergent? Yes, can I declare this?
Yes, sir.
Yes, and therefore this sum is finite. Basically, sum is finite. Exact sum, that is a different story. That may not be easy job right now, but definitely sum is finite. To obtain the exact sum, you need some more techniques that we are not interested in at this moment. Right. So, so recall this. If xn is equal to 1 plus 1 by 2 factorial plus 1 by 3 factorial, 1 by n factorial, n belongs to n, then is sequence xn convergent? We have discussed this sequence already. Yes. Did we
Yes, sir.
discuss? So is it convergent?
Yes, sir.
The answer is yes. Right? And then why? Why this series, this sequence is convergent? Right? By same logic,
It
this
is
is a
monotonically increasing and it has a upper bound.
right bounded above. So you go back and see our previous notes, previous discussion. You will find that we have already discussed that this is a convergent, and therefore our question is uh, does series 1 upon n factorial, n is from 1 to infinity, converge, and why? And now answer is very easy. What is answer?
Yes, it converges.
So if you construct sequence of partial sums, we'll get exactly this sequence. And this sequence is convergent, and therefore this series is convergent. Right. Therefore, uh, that's why we discuss those problems while talking about sequences. Right. And this series is convergent. Now observation. Okay, let me take one more example so that we can make some observation. Okay, this is my series now. Do you understand what is my series? Minus 1 plus 1 minus 1 plus 1 minus 1 plus 1. Right? Is it clear? Whatever I have written is correct?
Yes, sir.
Is this series convergent? Convergent. Is it convergent? Basic question, is it convergent?
No.
No. Answer is no. Why? So let us look at sequence of partial sums. What is x1? Sequence of partial sums. So what is x1?
-1.
Right. Because what is an here? Minus 1 raised to n. And therefore what is x1 is a1. So minus 1. Right. Now you tell me what is x2? a1 plus a2. What is a1 minus 1? a2 is 1. So 0. Am I right? Yes.
Yes, sir.
a1 x3 is a1 plus a2 plus a3. What is it? Minus 1 plus 1 minus 1. What is it? Again minus 1. And therefore, what is sequence xn? What is sequence xn? Therefore, sequence xn is minus 1, 0, minus 1, 0, minus 1, 0, and so on. Now my question is xn convergent? Right? Is xn convergent?
No.
Right, because we can produce two subsequences of the sequence which converge to different numbers. Therefore, this sequence is not convergent. So, why? Answer is no. Is it clear that this sequence is not convergent? There is no confusion. And why it is not convergent? So you can write down detail key. There are two subsequences which do not converge to same number. So the sequence is divergent. And therefore, what can you say about series? Is divergent. Okay, is it clear?
Yes, sir.
Is it? Yes. So, observations. So, series 1 by n square is convergent. An is equal to 1 by n square and limit of an is 0. Yes. Second observation. series 1 by n factorial is convergent. What is the nth term of series 1 by n factorial, and what is the limit of an? 0. Third observation, series minus 1 raised to n is divergent, and what is an here? Minus 1 raised to n, and what is limit of an? Does not exist. Right. So limit an in this case does not exist. So this is observed. Is it clear? Whatever I have written now, is it clear?
Yes, sir.
Right. And therefore, can you make some general statement? Can you make general statement? Right. So what should be the general statement? If series is convergent, then if series is convergent, then limit of an is necessarily 0. This is one way convergent implies. Right. I have written statement in one way. Then, right, implies. So that is series an is convergent implies limit of another term of series, not sequence. Now I am not looking at sequence of partial sums, is necessarily 0. This is what this theorem says. So from previous example, this theorem is very satisfied, right? But is it true in general? And proof is not very difficult. So assume that the series an is convergent. Right, this is our assumption. What we claim, what we claim, what we claim, limit of an as n tends to infinity is 0. Right, this is our claim. Correct? Okay, so is it clear what is going on?
Yes, sir.
Okay. Now to achieve this claim, now consider a sequence of xn of partial sums of series an. So therefore, xn is equal to a1 plus a2 plus an. Right? So xn is sequence of partial sums, and therefore, can we say that xn is convergent? Can we say that xn is convergent? Yes. Sequence xn is convergent or not? Is our assumption. Series is convergent. This we are assuming. Therefore, can we say that sequence of partial sums is convergent?
Yes, sir.
Right. So let x is equal to limit of sequence of partial sums. Right. Then for n greater than 1, what is limit n tends to infinity xn minus 1. What is this limit?
X.
Is also x because it is just one step before xn, right? Xn minus one step, and so ultimately following same terms. So this is also x. So now what is xn minus xn minus 1? Just calculate. What is xn? A1 plus a2 plus up to an. And what is xn minus 1? A1 plus a2 plus up to an minus 1. Right, and what is here? An minus 1. So ultimately what is the difference? A1 A1 A2 A2 an minus 1 an minus 1 up to an minus 1. It cancel, what remains? A. And therefore what is limit of an as n tends to infinity? This is true for all n greater than 1, right? Xn minus 1 is an. This is true, and therefore for all n this is true. So let us take limit as n tends to infinity. So limit as n tends to infinity of xn minus, because an is nothing but xn minus 1, right? By algebra of limits, what is it? Limit as n tends to infinity xn minus limit as n tends to infinity of xn minus 1. But what is limit of xn is x, limit of xn minus 1 is also x, and therefore 0. So is proof clear?
Yes,
Yes,
sir.
sir.
Right, very good. And therefore what the significance of this theorem? So thus what we have proved that what we have proved is series an is convergent implies limit of an is 0. This is what we have proved. What is the equivalent or contrapositive to this? That is, right, this is my statement P, this is my statement Q. P implies Q is equivalent to negation of Q implies negation of P. That is, what is the negation of P? Negation of Q. What is negation
Limit
of
of an is not equal to 0.
limit of an is not 0 implies series an is divergent. Right. So this is a very interesting thing which we have found. Right. So therefore, and therefore this criteria is very useful to decide with if sequence is divergent. So 2n plus 3 upon 5n plus 7. N is from 1 to infinity. Is series, is it convergent? Is this series convergent? Right? My an here, what is an? 2n plus 3 upon 5n plus 7, right? This is my nth term of the series. I am not looking at sequence at this instant. I have to just look at the term of series and evaluate the limit. If limit n is not 0, definitely series is divergent. Correct? So what is limit an? What is limit
2
an?
by 5.
2 by 5, which is non-zero. Right? Can I declare that this sum is infinite or does not exist?
Yes, sir.
Is
Yes, sir.
right? Sum is not finite or does not exist. So series is divergent. So this is a very interesting thing which is from this theorem. And in that sense, this statement is very important or essential. Immediately we'll check whether sum is finite or exist or not. So, and if you apply same criteria to this series, then what is an? Minus 1 raised to n. So limit an does not exist. Right, we want limit 0. So if limit is not 0 means either it exists but not 0, or does not exist, then what is the conclusion? Right, in 1 second we can say this is diversion. Right, so you think about this. I will give for exercise. So right, you just discuss the convergence of this, because you know limits of this. Right, so you discuss the convergence of this series, just observing limits of nth term. Right, okay, is it clear now?
Yes, sir.
Okay, so we'll stop here. If you have any difficulty,